Hi everyone. It's good to be able to chat about databases and R and geek out a bit on a Saturday afternoon. So thank you for the invite and thank you for the opportunity. This is a little bit of a kind of brain dump in that it's something that I've been thinking about for a while with my own research, and it's kind of something I think we need to have a conversation about, kind of how we deal with periods, how we deal with chronology, and kind of really how we deal with time. And that gives me an excuse to put in some random Doctor Who slides into my presentation. So that's the only really excuse for doing this. Apologies to anyone that doesn't know who Doctor Who is. Go look at Doctor Who. It's a great TV series, and there's lots of wonderful kind of historical inaccuracies in it as well. So kind of really, I'm going to talk about time. I'm going to talk about time in terms of data synthesis. Now, I was reminded the other day that I'm now long in the tooth as a zoo archaeologist, in that my PhD was quite a while ago. And but I've been doing data synthesis for quite a long time now. It was the foundation of my PhD that looked at animal burials from Neolithic to late medieval across Britain. That was in effect a data synthesis project. And I've been dealing with data synthesis, and my research has really been a matter of data synthesis kind of from that point onwards. How I dealt with time, actually, in preparing this paper, I looked back and thought, how did I deal with time back in PhD? And the honest answer is really rather simply, in that a lot of these animal burials had date ranges. So you can see in the database there, some are kind of early, some have quite tight date ranges where they tell you the actual date. Others might be it's Middle Roman to late Roman. And what I did for my PhD was I just basically used the latest date. So I just kind of went, well, I'll use the latest date as a TPQ. And that's kind of what I'll do going forward. I was honest about it, but in reality, it's a little bit simplistic. And it means you end up kind of producing graphs such as the one on the bottom, where you're just splitting things into early, middle, and late Roman, which have a relevance if you're talking just about kind of Britain, but when suddenly you're starting to compare out to other parts of Europe, make it a little bit more kind of problematic. So I kind of moved on from that kind of research-wise, and really kind of for the last 10 years, what I've been doing is urban zoo archaeology, primarily because just after my PhD, I ended up as the zoo archaeologist for Mola for a while before going back into academia. So I ended up kind of doing a number of projects, such as with Richard and Monte, looking at size changes in medieval and post-medieval animals in London, and then with David and Alison and James looking at fish remains in London as well. And what's interesting is kind of how we dealt with chronology and how we dealt with time in those different kind of projects. I'll get back to the kind of the fish one, but for the metrics one I did with Richard and Monte, we started out with an initial data set of about 87,000 measurements, most of it from the Mola database, which is kind of a fantastic data set. We had to kind of course do some cleaning, so we removed the mad measurements. So there were some chickens that were the size of Tyrannosaurus rexes in there, primarily where there's just been typos when someone's entering the data. And then kind of we narrowed down to our interest in time periods. We wanted to look at medieval and post-medieval, so that goes down to 45,000. And then we had to deal with the matter of date range, in that actually an awful lot of the remains we were looking at had date ranges longer than 300 years. And how then do we start to put those into some kind of useful chronology? So we actually excluded anything with date range of over 300 years. There's the issue of residuality in terms of looking at urban materials. Not something I'm going to touch on today, but it is kind of a separate kind of issue. And really after doing that, we ended up using just 28% of the metrical data that we'd initially gathered. So actually in trying to deal with the chronological issues, we end up losing an awful lot of data. And then what we did is we put the chronologies into, you can see on the graph there, kind of some overlapping kind of time periods. So for example, elements of C overlap with B and overlap with D as well. So that was kind of one strategy in terms of dealing with chronology when start trying to do zooarchaeological synthesis. So it's something that is still kind of at the forefront of my mind, because I'm currently working on an urban zoo archaeology project in that my wife says I made a mistake in that I agreed to write a book. It probably was a mistake, but I'm currently kind of working on a book project on urban zoo archaeology. It should be out in about 2 years' time. I've got to say, I'm not one of these people that has had a very productive lockdown. So 2 years is about right for it to be out. And for this, I'm kind of looking at synthesizing data from 15 plus urban centres in Northern Europe, and I'm using published and unpublished kind of data sources. But the underlying kind of issue with doing this for this kind of project is time, is actually how do you deal with the fact that you've got disparate data sets from, in the case of London, nearly 400 separate excavations, all of them using slightly different time periods for their chronologies, and you've got to try and mash them all together to get something useful out of them. Just as an example of kind of why time kind of is an issue, this is, I'm going to use kind of for the rest of this presentation, just dogs in London, because it's kind of quite a useful way of just kind of looking at this issue and this data. And this is just a simple plot of the NISP counts of for dogs in London from the data set that I've kind of gathered. And I've put it into kind of archaeologically defined kind of time periods, which is another issue we probably should talk about at some point. But you'll notice actually the majority, the largest kind of bar chart is the one on the right, which is rejected, which is basically they represent dog remains that I couldn't put into one of these archaeologically defined time periods because their date range was just so long. And the table at the top kind of shows just an example of that. You get some deposits that have really tightly defined date ranges, such as the 85 dog bones that have just got an early date and a later date of 60 to 70 AD. Great. But you get others where the date range is Roman or medieval, which makes it much, much more problematic to then kind of incorporate into your data. One of the ways we got around this with looking at fish in London, and I should praise David Orton, because he's the one that came up with this strategy, is to use heuristic analysis. And it was a useful strategy for looking at fish of London, and it's useful for kind of looking at other kind of data sets as well. And how this works is what you do is you define your bin width. So the bin is just kind of your chronological blocks in effect, and then you'll calculate kind of in effect the NISP per bin. So say, for example, the example at the top of that table, AA21, has a start date of 40 AD, has an end date of 60 AD. We've got a NISP of 6 dogs. If we were to have a bin width of 10 years, then we're looking at kind of 3 dog bones every 10 year block. And what you can do then is you can use this information, and actually you can do this in Excel to build up a frequency diagram. And you can think of that in terms of Tetris. And I stole that idea from David as well. He won't mind. So there's our AA21 kind of context going in with its 3 dog bones every 10 years. And then we'll put on top of that the BB21, and gradually you end up kind of building up this kind of frequency diagram depending upon kind of the bin width. And then finally, kind of our last site kind of goes in. And what you end up with then is you end up actually with a much more detailed chronological overview of what's going on with some of the frequency data for your species. So you end up kind of with a graph like that. And this is what it looks like calculated for London for the NISP counts just for dogs. So this is actually better than just our simplistic kind of early, middle and late Roman, early, middle and late Anglo-Saxon kind of way of looking at our data sets. It's much more detailed, but it does come with its own issues and problems. One of them is you have to have an understanding of how the material has been dated in the first place. So you'll see on this graph, the highest peak is one just at the very start of the Roman period. So it's this kind of 30 to 60 kind of AD bracket. And then our second highest is over here in the 1600s. And the reason we've got those two peaks in those two places is because of the Boudiccan revolt and the Great Fire of London. And in effect, what we have in London is you've got a archaeological context with a known time period associated with it. So if that is capping some of your earlier contexts, then it gives you a very definitive end date. So you end up with some really tightly defined archaeological context around those periods. Yet in other kind of time frames, so such as the later Roman, we don't have such key tightly defined context. So you end up kind of much more spread out of your data. But this heuristic kind of method does allow you, though, to still look at some of the patterns kind of in your data in much more detail than just kind of a simplistic kind of, let's put it into archaeologically defined early, mid, and late kind of example. It does, though, have one kind of fundamental big question, and it leads you to question how was the material deposited in the first place? So how the heuristic analysis is in effect assuming that your material has gradually built up over time. And for some archaeological context, this is correct. So for example, we've got some ditch context where you do have very gradual buildup of material over time. There's silting layers in there. You know that is how the material was building up. But then you have other archaeological contexts where this is most probably not the case. And actually what you're looking at is you're looking at a single defined event. So an animal burial would be kind of a classic example. Or this here is not a great picture, it's a picture of a soup kitchen, Roman soup kitchen deposit in London. Or this is basically a pit that's absolutely chocker full of animal bone. And it looks like it was all kind of deposited all at once, all at the same time. In which case, then actually your start and end dates just represent probability data. At some point from your start date to your end date, this one event kind of happened. And in which case, your heuristic analysis then isn't really doing you any favors because it's just spreading out that event over that time range. So it can work and it can show you some useful information, but it, as with every methodology, it has some problems. It also is a bit more problematic if you want to then look just beyond your simplistic element or species count data. So for example, this is dogs' withers height data from London. And so this is just split into centuries. So we've got kind of first all the way through into the 19th kind of century. The reason I'm showing withers height rather than any other metric is because I've combined unpublished grey literature and published data. A lot of the published sources where I don't have access to the raw data, it would just give us a withers height, it won't give us the actual measurement that goes behind the withers height. But still, this kind of nicely shows that there's some patterns in there, but this is the data plotted using just the earliest date. And this is the exact same withers height data plotted using just the latest date. So it's the same measurements, but we've just gone from one end of the date range to the other. But of course, you can see, if I just kind of flip back and forth, it does end up with some fundamental changes to your data. So everything that was in the first century has moved into the second. We had a very small dog in the 13th century has moved up to the 16th century, and you've suddenly got this large concentration of larger dogs in the 19th century. As well. So there are a number of kind of issues with doing this. One possibility to kind of get around this is to use another method that we ended up using in one of our second papers on the fish, when looking at fish from London, and that was to do some simulations, basically Monte Carlo simulation in R. And that uses, that also involves you setting your own kind of bin width. So for this example, let's say kind of 5 years. And rather than assuming like the heuristic analysis, where everything is kind of spread out over that time period, the simulation assumes everything is deposited at once, and that actually your start and end dates just are the date range in which some point it randomly picks a point in that date range to go, that's when the things are deposited. So what you do is you run kind of one analysis where you might end up with that's when the material is deposited, and then you run a second analysis, and then you run a third simulation. And gradually over time, you do this about 2,000 plus times, and what you end up is with an estimated frequency density. And this is the estimated frequency density for dogs, just from the Roman period, kind of in London. And it nicely shows us that actually we do have a distinct kind of increase in the frequency, or likely to have a distinct increase in the frequency of dogs moving into that kind of later Roman time period. But then that kind of raises another problem in that, how then do we then start to attach in our withers height data? So that's fine for looking at species and elements, but actually we want to think about kind of our metrical data, or maybe our tooth-wear data, or maybe our pathology data kind of in there as well. So I was kind of thinking about this problem while at the same time we were being restructured into a school that thankfully included mathematicians. And so I ended up having one of these awful kind of meet and greet breakout rooms where I struck up a conversation with the course leader in maths. I'm the course leader in archaeology, and we bonded over R, which is always a wonderful thing to do. And he suggested, well, actually what you're really want to produce is a summed probability distribution, but you could actually do it as a scatter plot if you want to include in your withers height data, because in effect your withers height is your Y and your time period is your X, and you just basically what you've got in your simulation is lots of dots along one X-axis, but the Y-axis always remains the same. So I was like, okay, let's get R fired up and let's do that. And what we ended up producing was this. So this is the estimated frequency of withers heights for dogs from London from a simulation. So using that simulation approach, where what we've got at the bottom is our chronology, and then what we've got on the left hand side is our withers height. And I've just put in kind of three rough outlines of dogs. So we've got kind of our Jack Russell down at the bottom. We've got kind of roughly in that 400 to 500 millimeters range. We've got our kind of golden retriever, and then our wolfhound kind of all the way at the top. This shows kind of 10-step kind of concentration, and I could put in the legend for that, but actually it would be relatively meaningless because this is a simulation that's run 2,000 times. So there are thousands upon thousands of data points kind of in there. So actually what we're really looking for here is just patterns. And actually that's great, because that, as a zoo archaeologist, that's kind of what I want. I very much agree with the earlier paper where it's talking about getting away from kind of p-values. We need to just kind of be looking at data visualization and thinking about our patterns, because our data is really messy as archaeologists. So one of the great things about this is it nicely is showing in that Roman period, we've got kind of two different almost kind of size groupings of dogs. The Anglo-Saxon period is, of course, very difficult. The medieval period, we've got hardly any data. But then moving into the medieval period, we've got a kind of real concentration in the 12th to the 1400s of, in fact, golden retriever size kind of dog. And then we've got kind of a gradual increase into our smaller animals. But it's this kind of concentration up here in the 1700s of a much larger animals, kind of greyhound size, that actually was what I was really pleased to see, because this nicely starts to then tie in with some of the historical data on dogs from urban centres. So within the zoo art literature, there's often a kind of a dichotomy when looking at sizes of dogs. You've basically got small little dogs are pets, lap dogs. So small little dogs, lap dogs, they are pets. Bigger sized dogs in an urban setting, they are strays. And that kind of tends to be the kind of underlying narrative sometimes to when looking at kind of dog sizes. Whereas what's actually interesting in looking at kind of the history of animals in an urban centre is that you have an awful lot of working dogs in places such as London in the 16th, 17th, 18th century. They are not kind of, they are not sheepdogs, but they are guard dogs, and they are doing all sorts of kind of other jobs as well, such as transport.
Sorry to interrupt.
Oh, well, I'm running out of
just
time.
Running a bit out of time, yeah.
Okay, that's basically the end. So we get to that, and my conclusion slide is we need to just be a bit more honest and think about how we are using kind of time when we come to these big data synthesis, when we come to data synthesis. And my thanks to David and to Chris, who helps me with sort of the art as well. Okay, I'll stop sharing my screen.